In this lesson, you'll be learning about similar triangles. Your learning target is, I can use numeric and algebraic strategies to solve problems involving similar figures. First, before we get into similar triangles, let's review some prior knowledge that will be helpful. In the first example, I'm asking you to solve for x. You could think about equivalent fractions. You could look for a relationship involving multiplication in the numerators, that 3 times 4 equals 12. So that same multiplication relationship would exist in the denominators, that some denominator times 4 equals 20. Therefore, x would equal 5. So this value of x equals 5 means that the fractions 3/5 and 12/20 are equivalent. In the next example, solving this proportion, I'm looking at the denominators, and I don't see an immediate relationship between 6 and 15. I realize this is a proportion, which is a math sentence that sets two ratios equal, and I'm remembering a property of proportions called cross products, that in a proportion, cross products are equal. That is, the product of one denominator times the other numerator, so 15 times x would equal 10 times 6, or 60. And now that I have this equation, I can divide both sides by 15, giving me x equals 4. I can check that that value of x makes sense. If I plug it back into the fraction on the right, 4/6 is equivalent to 2/3, and the fraction on the left, 10/15, is also equivalent to 2/3. So now let's move on to our new concept of similar triangles. They are triangles that have congruent corresponding angle measures. So in a pair of similar triangles or similar figures, angles that correspond will be congruent, but side lengths that correspond are going to be proportional. We have an example. Two triangles are given. The triangle on the left is clearly larger than the triangle on the right. So let's check the corresponding side lengths. Let's look at side NM compared to SR, and that would be 8/6. Let's look at sides ML and RQ. That would be 12/9. And let's look at the shortest sides, LN and QS. That would be 4/3. All three of these ratios are equivalent. They all simplify to 4/3. Therefore, this pair of triangles is definitely similar. So we're going to use corresponding side lengths and solve for some missing sides. In our first example, we're looking for x. I can take a look at that triangle on the right and see a relationship of the side marked as 8 and the side marked as 16, realizing that fraction simplifies to a half. That ratio is equivalent to x/7. So to solve for x, it's just a matter of dividing 7 by 2. X would equal 3.5. That's one way I could solve that missing side length. Let's look at the next example. This one is not as straightforward because the triangles are not configured the same way. So instead of looking at the diagram to help me write my proportion, I'm going to look at the given similarity statement. I know that I'm trying to find the side marked as ML. So I can write a proportion. ML over PT is equivalent to MQ over PS. Now I'm going to plug in my numbers from my diagram, that x/40 will be equal to 4/20. I'm noticing there's a relationship that's quite obvious in the denominator there. 20 times 2 is 40. So that same relationship exists in the numerators. 4 times 2 would equal x. X equals 8. So now you have a couple of sample problems, and we want you to try to solve 2 of these on your own. You're going to solve for x in each example. Please put the video on pause, see if you can come up with the value of x, and then come back and check. All right, so the example on the left, there's many ways you could begin. I began by looking at the ratio of the sides marked 3 and x. And I said that 3 over x equals 12 over 18. From there, I applied the cross product property that 12x is equal to 54. Dividing both sides by 12, I get x equals 4.5. Did you get the same value of x? And was your way into solving this problem similar, or did you use a different strategy? The example on the right, I'm looking at the given similarity statement because these triangles are not configured the same way in the diagram. I'm going to realize I'm solving for MR, so I want to write a proportion that MR is to QF as RS is to FP. Now I want to substitute in the values from the diagram. X over 6 equals 20 over 8. I want to apply the cross product property that 8x is equal to 120, and now divide both sides by 8, giving me x is equal to 15. All right, finally, we have an error analysis problem. And here we are given 2 right triangles. We're told that the triangles are similar, and we have to describe and correct the error. So some student has done some work for this problem, and they got that x equals 12. And we need to convince the student why x does not equal 12. So take a moment, check out the diagram, check out the student's work, and what would you say to this student? So for me, when I look at the diagram, I realize the scale factor between the small and the large triangle is 2. Because the height, 8 times 2 equals 16. So therefore, the hypotenuse is, I could also multiply 10 by the scale factor of 2 to get x. X would actually equal 20. Now I look at the student's work and I'm thinking, what might they have done wrong? They started off correctly, 8 over 16, but they set that equal to 6 over x. 6 and x are not corresponding sides. So a better proportion would have been 8 over 16 equals 10 over x. Now we can use the cross product property that 8x is equal to 160. Dividing both sides by 8, I get that x is equal to 20.